Good wishes to all of you. India Physical Environment Textbook in Geography for Class 11, Part 2. Unit 4 Natural Hazards and Disasters Causes, Consequences, and Management. This unit deals with floods and droughts, earthquakes and tsunami, cyclones, landslides. Chapter 7 Natural Hazards and Disasters Audiobook. You might have read about tsunami or you seen the images of horror on television set immediately after it happened. You may also be aware of the severe earthquake in Kashmir on both sides of the line of control LOC. The damage caused to human life and properties during these episodes has moved us all. What are these as phenomena and how they are caused? How can we save ourselves? These are some questions which come to our minds. The chapter will attempt to analyze some of these questions. Change is the law of nature. It is a continuous process that goes on uninterruptedly, involving phenomena, big and small, material and non-material, that make our physical and socio-cultural environment. It is a process present everywhere with the variations in terms of magnitude, intensity, and scale. Change can be a gradual or slow process like the evolution of landforms and organisms, and it can be as sudden and swift as volcanic eruptions, tsunamis, earthquakes, and lightning, etc. Similarly, it may remain confined to a smaller area occurring within a few seconds, like hailstorms, tornadoes, and dust storms, and it can also have global dimensions such as global warming and depletion of the ozone layer. Besides, these changes have different meanings for different people. It depends upon the perspective one takes while trying to understand them. From the perspective of nature, changes are value neutral, these are neither good nor bad. But from the human perspective, these are value loaded. There are some changes that are desirable and good like the change of seasons, depending of fruits, while there are others like earthquakes, floods, and wars that are considerable bad and undesirable. Observe the environment you live in and prepare a list of changes which take place over a long period of time and those which take place within a short period of time. Do you know why some changes are considered good and others bad? Prepare a list of changes which you notice in your daily life and give reasons why some of these are considered good and others bad. In this chapter, we will read about some of these changes which are considered bad and have haunted humankind for a long time. Disasters in general and natural disasters in particular are some such changes that are always disliked and feared by humankind. What is a disaster? Disaster is an undesirable occurrence resulting from forces that are largely outside human control, strikes quickly with little or no warning, which causes or threatens serious disruption of life and property, including death and injury to a large number of people, and requires therefore mobilization of efforts in excess of that which are normally provided by statutory emergency services. For a long time, geographical literature viewed disasters as a consequence of natural forces, and human beings were treated as innocent and helpless victims in front of the mighty forces of nature. But natural forces are not the only causes of disasters. Disasters are also caused by some human activities. There are some activities carried by human beings that are directly responsible for disasters. Bhopal gas tragedy, Chernobyl nuclear disaster, wars, release of CFCs, chlorofluorocarbons, and increase of greenhouse gases, environmental pollution like noise, air, water, and soil are some of the disasters which are caused directly by human actions. There are some other activities of human beings that accelerate or intensify disasters indirectly. Landslides and floods due to deforestation, unscientific land use, and construction activities in fragile areas are some of the disasters that are the results of indirect human actions. Can you identify some other human activities going on in and around your neighborhood and schools that can lead to disasters in the near future? Can you suggest some measure to prevent it? It is a common experience that human made disasters have increased both in their numbers and magnitudes over the years, and concerted efforts are on at various levels to prevent and minimize their occurrences. Though their success has been only nominal so far, it is possible to prevent some of these disasters created by human actions. As opposite to this, very little is possible to prevent natural disasters. Therefore, the best way out is to emphasize on natural disaster mitigation and management. Establishment of National Institute of Disaster Management India at summit at Rio de Janeiro, Brazil 1993, and the World Conference on Disaster Management in May 1994 at Yokohama, Japan, etc. are some of the concrete steps towards this direction initiated at different levels. Most often, it is observed that scholars use disasters and natural hazards as interchangeable. Both are related phenomena, as yet quite sorry yet quite distinct from each other. Hence, it is necessary to distinguish between the two. Natural hazards are elements of circumstance in the natural environment that have the potential to cause harm to people or property or both. These may be swift or permanent aspects of the respective environment settings like currents in the oceans, steep slope, and unstable structure. Features in the Himalayas or extreme climatic conditions in deserts or glaciated areas. As compared to natural hazards, natural disasters are relatively sudden and cause large scale, widespread death, loss of property, and disturbance to social systems and life over which people have little or no control. Thus, an event can be classed as disaster when the magnitude of destruction and damage caused by it is very high. Generally, disasters are generalized experiences of people the world over, and no two disasters are similar and comparable to each other. Every disaster is unique in terms of the local socio environment factors that control it, the social response it generates, and the way each social group negotiates with it. However, the opinion mentioned above is indicative of three important things. Firstly, the magnitude, intensity, frequency, and damages caused by natural disasters have increased over the years. Secondly, there is a growing concern among people the world over to deal with the menace created by these so that the loss of human life and property can be minimized. And finally, significant changes have taken place in the pattern of natural disasters over the years. There has also been a change in the perception of natural disasters and hazards. Previously, hazards and disasters were seen as two closely associated and interrelated phenomena, that is, areas prone to natural hazards were more vulnerable to disasters. Hence, people avoided tampering with the delicate balance that existed in a given ecosystem. People avoided intensification of their activities in such areas, and that is how disasters were less damaging. Technological power has given large capacity to human intervention in nature. Consequently, now human beings tend to intensify their activities into disasters prone areas, increasing their vulnerability to disasters. Colonization of flood plains of most of the rivers and development of large cities and port towns like Mumbai and Chennai along the coast and touching the shore due to highland values make them vulnerable to the occurrence of cyclones, hurricanes, and tsunamis. These observations can also be cor- corroborated by the data given in Table 7.1, showing the magnitude of deaths caused by 12 serious natural disasters in the past 6 years in different countries of the world. It is evident from the table that natural disasters have caused widespread loss of life and property. Concentrated efforts are on at various levels to take appropriate measures to deal with the situation. It is also being felt that the damages caused by natural disasters have global repercussions that are beyond the means and capabilities of individual nation states to cope up with. Hence, this issue was raised at the UN General Assembly in 1989, and it was finally formalized at the World Conference on Disaster Management in May 1994 at Yokohama, Japan. This was subsequently called the Yokohama Strategy and Plan of Action for a Safer World. Take a look at Table 7.1 Some natural disasters since 1948. Year, location, type, deaths. 1948 The Soviet Union, now Russia. Earthquakes 110,000. 1949 China, floods 57,000. 1954 China, floods 30,000. 1965 East Pakistan, now Bangladesh, tropical cyclones 36,000. 1968 Iran, earthquakes 30,000. 1970 Peru, earthquakes 66,794. 1970 East Pakistan, now Bangladesh, tropical cyclones 500,000. 1971 India, tropical cyclones 30,000. 1976 China, earthquakes 700,000. 1990 Iran, earthquakes 50,000. 2004 Indonesia, Sri Lanka, India, etc. Tsunamis 500,000. 2005 Pakistan, India, earthquakes 70,000. 2011 Japan, tsunami 15,842. Source United Nations Environmental Programme UNEP 1991. News report from National Institute for Disaster Management, Government of India, New Delhi. Take a look at Table 2 7.2 Classification of Natural Disasters: Atmospheric, Terrestrial, Aquatic, Biological. Blizzards, thunderstorms, lightning, tornadoes, tropical cyclone, drought, hailstorm, frost, heat wave or low, cold waves, etc. Terrestrial: earthquakes, volcanic eruptions, landslides, avalanches, subsidence, soil erosion. Aquatic: floods, tidal waves, ocean currents, storm surge, tsunami. Biological: plants and animals as colonizers, locusts, etc. Insects infestation, fungal, bacterial, and viral disease such as bird flu, dengue, etc. Classification of natural disasters: human beings the world over have experienced the disasters and have faced and lived with them. Now people are becoming aware and various steps have been initiated at different levels for mitigating the effects of disasters. Identification and classification of disasters is being considered as an effective and scientific step to deal promptly and efficiently with the disasters. Broadly, natural disasters can be classified under four categories. See Table 7.2. India is one of those countries which has experienced most of the natural disasters mentioned in Table 7.2. Every year, it loses thousands of lives and property worth millions of rupees due to these natural calamities. In the following section, some of the highly devastating natural disasters have been discussed, particularly in the context of India. Yokohama Strategy and International Decade for Natural Disaster Reduction (IDNDR). Yokohama Strategy and Plan of Action for a Safer World. All the member states of the United Nations and other states met at the World Conference on Natural Disaster Reduction in the city of Yokohama from May 23rd to 27, 1994. It acknowledged that the impact of natural disasters in terms of human and economic losses has risen in recent years, and society in general has become vulnerable to natural disaster. It also accepted that these disasters affected the poor and disadvantaged groups the worst, particularly in the developing countries, which are ill equipped to cope with them. Hence, the conference adopted the Yokohama strategy as a guide to rest of the decade and beyond to mitigate the losses due to these disasters. The resolution of the World Conference on Natural Disaster Reduction is as mentioned below. It will note that each country has the sovereign responsibility to protect its region from natural disasters. It will give priority attention to the developing countries, particularly the least developed, landlocked countries, and small island developing states. It will develop and strengthen national capacities and capabilities, and where appropriate, national legislation for natural and the other disaster prevention, mitigation, and preparedness, including the mobilization of non governmental organisms and participation of local communities. It will promote and strengthen sub regional, and international cooperation in activities to prevent, reduce, and mitigate natural and other disasters with particular emphasis on human and institutional capacity building and strengthening. technology sharing, the collection, the dissemination and utilization of information, and mobilization of resources. It also declared and decaded 1990 to 2000 as the International Decade for Natural Disaster Reduction (IDNDR). Natural disasters and hazards in India. It was discussed in one of the previous chapters that India is vast and diverse in terms of its physical and socio-cultural attributes. It is largely due to its vast geographical area, environmental diversities, and cultural pluralities that scholars often describe it using two meaningful adjectives like the Indian subcontinent and the land of unity in diversity. Its vastness in terms of natural attributes combined with its prolonged colonial past containing various forms of social discrimination and also equally large population have enhanced its vulnerability to natural disasters. These observations can also be illustrated by focusing on some of the major natural disasters in India. Earthquakes. Earthquakes are by far the most unpredictable and highly destructive of all the natural disasters. You have already learned the causes of earthquakes in your book Fundamentals of Physical Geography NCERT 2006. Earthquakes that are of tectonic origin have proved to be the most devastating, and their area of influence is also quite large. These earthquakes result from a series of earth movements brought about by a sudden release of energy during the tectonic activities in the earth's crust. As compared to these, the earthquakes associated with the volcanic eruption, rockfall, landslides, subsidence, particularly in the mining areas, impounding of dams and reservoirs, etc., have limited area of influence and the scale of damage. It was mentioned in chapter 2 of the book that the Indian plate is moving at a speed of 1 centimeter per year towards the north and northeastern direction, and this movement of plates is being constantly obstructed by the Eurasian plate from the north. As a result of this, both the plates are said to be locked with each other, resulting in accumulation of energy at different points of time. Excessive accumulation of energy results in building up of stress, which ultimately leads to the breaking up of the lock, and the sudden release of energy causes earthquakes along the Himalayan arch. Some of the most vulnerable states are Jammu and Kashmir, Himachal Pradesh, Uttarakhand, Sikkim, and the Darjeeling and subdivision of West Bengal, and all the seven states of the northeast. Take a look at figure 7.1, a damaged building due to an earthquake. Apart from these regions, the central western parts of India, particularly Gujarat in 1819, 1956, and 2001, and Maharashtra in 1967 and 1993, have also experienced some severe earthquakes. Yet the scientists have found it difficult to explain the occurrence of earthquakes in one of the oldest, most stable, and mature landmass of peninsular block for a long time. Recently, some earth scientists have come up with a theory of emergence of a fault line and energy build up along the fault line represented by the river Bhima, Krishna near Latur and Osmanabad, Maharashtra, and the possible breaking down of the Indian plate, figure 7.2. National Geophysical Laboratory, Geological Survey of India, Department of Meteorology, Government of India, along with the recently formed National Institute of Disaster Management, have made an intensive analysis of more than 1200 earthquakes that have occurred in India in different years in the past. And based on these, they divided India into the following five earthquake zones: very high damage risk zone, high damage risk zone, moderate damage risk zone, low damage risk zone, very low damage risk zone. Out of these, the first two zones had experienced some of the most devastating earthquakes in India, as shown in the figure 7.2. Areas vulnerable to these earthquakes are the northeast states, areas to the north of Darbhanga and Araria along the Indo-Nepal border in Bihar, Uttarakhand, Western Himachal Pradesh, around Dharmashala and Kashmir Valley in the Himalayan region, and the Kutch, Gujarat. These are included in the very high damage risk zone. Similarly, the remaining parts of Jammu and Kashmir, Himachal Pradesh, northern parts of Punjab, eastern parts of Haryana, Delhi, western Uttar Pradesh, and northern Bihar fall under the high damage risk zone, Remaining parts of the country fall under moderate to very low damage risk zone. Most of the areas that can be considered safe are from the stable landmass covered under the Deccan Plateau. Socio-environmental consequences of earthquakes. The idea of an earthquake is often associated with fear and horror due to the scale, magnitude, and suddenness at which it spreads disasters on the surface of the earth without discrimination. It becomes a calamity when it strikes the areas of high density of population. It not only damages and destroys the settlements, infrastructure, transport, and communication network, industries, and other developmental activities, but also robs the population of their material and socio-cultural gains that they have preserved over generations. It renders them homeless, which puts an extra pressure and stress, particularly on the weak economy of the developing countries. Effects of earthquakes. Earthquakes have all encompassing disastrous effects on the areas of their occurrence. Some of the important ones are listed in Table 7.3. Table 7.3 Effects of earthquakes on ground, on man made structures, on water. On ground, fissure settlements, landslides, liquefac- liquefaction, earth pressure possible, chain effects. On man made structure, cracking slides, overturning, buckling, collapse, possible chain effects. On water, waves, hydrodynamic pressure, tsunami, possible chain effects. Take a look at figure 7.2 India earthquake hazard zones. Apart from these, earthquakes also have some serious and far reaching environmental consequences. Surface seismic waves produce fissures on the upper layers of the earth's crust through which water and other volatile materials gush out, inundating the neighboring areas. Earthquakes are also responsible for landslides, and often these cause obstruction in the flow of rivers and channels, resulting in the formation of reservoirs. Sometimes rivers also change their course, causing floods and other calamities in the affected areas. Earthquake hazard mitigation. Unlike other disasters, the damage caused by earthquakes are more devastating since it also destroys most of the transport and communication links. Providing timely relief to the victims becomes difficult. It is not possible to prevent the occurrence of an earthquake. Hence, the next best option is to emphasize on disaster preparedness and mitigation rather than curative measures such as establishing earthquake monitoring centers, seismological centers for regular monitoring, and fast dissemination of information among the people in the vulnerable areas. Use of geographical positioning system GPS can be of great help in monitoring the movement of tectonic plates, preparing a vulnerability map of the country, and dissemination of vulnerability risk information among the people, and educating them about the ways and means minimizing the adverse impacts of disasters, modifying the house types and building designs in the vulnerable areas, and discouraging construction of high rise buildings, large industrial establishments, and big urban centers in such areas. Finally, making it mandatory to adopt earthquake resistant designs and use light materials in major construction activities in the vulnerable areas. Tsunami. Earthquakes and volcanic eruptions that cause the seafloor to move abruptly, resulting in sudden displacement of ocean water in the form of high vertical waves, are called tsunamis, harbor waves, or seismic sea waves. Normally, the seismic waves cause only one instantaneous vertical wave, but after the incidental disturbance, a series of after waves are created in the water that oscillate between high crest and low throw in order to restore the water level. The speed of wave in the ocean depends upon the depth of water. It is more in the shallow water than in the ocean deep. As a result of this, the impact of a tsunami is less over the ocean and more near the coast, where they cause large scale devastations. Therefore, a ship at sea is not much affected by tsunami, and it is difficult to detect a tsunami in the deeper parts of sea. It is so because over deep water the tsunamis has very long wavelength and limited wave height. A tsunami wave rises the ship only a meter or two, and each rise and fall takes several minutes. As opposite to this, when a tsunami enters shallow water, its wavelength gets reduced and the period remains unchanged, which increases the wave height. Sometimes this height can be up to 15 meters or more, which causes large scale destruction along the shores. Thus, these are also called shallow water waves. Tsunamis are frequently observed along the Pacific Ring of Fire, particularly along the coast of Alaska, Japan, Philippines, and other islands of Southeast Asia, Indonesia, Malaysia, Myanmar, Sri Lanka, and India, etc. After reaching the coast, the tsunami waves release enormous energy stored in them, and water flows turbulently onto the land, destroying ports, cities, and towns, structures, buildings, and other settlements. Since the coastal areas are densely populated the world over, and these are also centers of intense human activity, the loss of life and property is likely to be much higher. A tsunami, as compared to other natural hazards in the coastal areas. The extent of devastation caused by tsunami can be assessed through the visual on Banda H. Indonesia presented in the book Practical Work in Geography Part 1 NCRT 2006. Unlike other natural hazards, the mitigation of hazards created by tsunami is difficult mainly because of the fact that losses are on a much larger scale. Take a look at figure 7.3 tsunami affected area. It is beyond the capacity of individual state or government to mitigate the damage. Hence, combined efforts at the international levels are the possible ways of dealing with these disasters, as has been in the case of the tsunami that occurred on 26 December 2004, in which more than 3 lakh people lost their lives. India has volunteered to join the international tsunami warning system after the December 2004 tsunami disaster. Tropical cyclone. Tropical cyclones are intense low pressure areas confined to the area lying between 30 degrees north and 30 degrees south latitudes in the atmosphere, around which high velocity winds blow. Horizontally, it extends up to 500 to 1000 kilometers, and vertically from surface to 12 to 14 kilometers. A tropical cyclone or hurricane is like a heat engine that is energized by the release of latent heat on account of the condensation of moisture that the wind gathers after moving over the oceans and seas. There are differences of opinion among scientists about the exact mechanism of a tropical cyclone. However, some initial conditions for the emergence of a tropical cyclone are large and continuous supply of warm and moist air that can release enormous latent heat, strong Coriolis force that can prevent filling of low pressure at the center. Absence of Coriolis force near the equator prohibits the formation of tropical cyclone between 0 degrees to 5 degrees latitude. Unstable condition through the troposphere that creates local disturbance around with a cyclone develops. Finally, absence of strong vertical wind which disturbs the vertical transport of latent heat. Structure of Structure of a tropical cyclone. Tropical cyclones are characterized by large pressure gradients. The center of the cyclone is mostly a warm and low pressure cloud, cloudless core known as eye of the storm. Generally, the isopods are closely placed to each other, showering high pressure gradients. Normally, it varies between 14 to 17 MB by 100 kilometers, but sometimes it can be as high as 60 MB by 100 kilometers. Expansion of the wind belt is about 10 to 50 kilometers from the center. Spatio-temporal distribution of tropical cyclone in India. Owing to its peninsular shape surrounded by the Bay of Bengal in the east and the Arabian Sea in the west, the tropical cyclones in India also originate in these two important locations. Though most of the cyclones originate between 10 degrees to 15 degrees north latitude during the monsoon seasons, yet in case of the Bay of Bengal, Cyclones mostly develop during the months of October and November. Here they originate between 16 degrees to minus 2 degrees north latitudes and to the west of 92 degrees east. By July, the place of origin of these storms shift to around 18 degrees north latitude and west of 90 degrees east near the Sundarban Delta. Take a look at figure 7.4, wind and cyclone hazard zones. It was mentioned that the energy to the tropical cyclone comes from the latent heat released by the warm moist air. Hence, with the increase in distance from the sea, the force of the cyclone decreases. In India, the force of the cyclone decreases with increase in distance from the Bay of Bengal and the Arabian Sea. So the coastal areas are often struck by several cyclonic storms with an average velocity of 180 km per hour. Often this results in abnormal rise in the sea level known as storm surge. A surge is generated due to interaction of air, sea and land. The cyclone provides the driving force in the form of very high horizontal pressure gradient and very strong surface winds. The sea water flows across the coast along with the strong winds and heavy downpour. This results in inundation of inundation of human settlements, agriculture fields, damaging crops, and destruction of structures created by human beings. Floods. You read in newspapers and watch images of floods on televisions occurring in some regions during rainy seasons. Inundation of land and human settlements by the rise of water in the channels and its spillover presents the condition of flooding. Unlike other natural disasters, the causes of floods are well established. Floods are relatively slow in occurrences and often occur in well identified regions and within accepted time in a year. Floods occur commonly when water in the form of surface runoff exceeds the carrying capacity of the river channels and streams and flows into the neighboring low lying floodplains. Sometimes this even goes beyond the capacity of lakes and other inland water bodies in which they flow. Floods can also be caused due to a storm surge in the coastal areas, high intensity rainfall for a considerably longer time period, melting of ice and snow, reduction in the infiltration rate, and presence of eroded material in the water due to higher rate of soil erosion. Though flood occur frequently over wide geographical area having disastrous ramifications in many parts of the world. Floods in the South, Southeast and East Asian countries, particularly in China, India and Bangladesh, are frequent and equally disastrous. Once again, unlike other natural disasters, human beings play an important role in the genesis as well as the spread of floods. Indiscriminate deforestation, unscientific agricultural practices, disturbances along the natural drainage channels, and colonizations of floodplains and riverbeds are some of the human activities that play an important role in increasing the intensity, magnitude, and gravity of floods. Take a look at figure 7.5, Brahmaputra during flood. Take a look at figure 7.6 map, flood hazard zones. Various states of India face heavy loss of lives and property due to recurrent floods. Rashtriya Bhar Ayog National Flood Commission identified 40 million hectares of land as flood prone in India. The figure 7.6 shows the flood affected areas in India. Assam, West Bengal, and Bihar are among the high flood prone states of India. Apart from these, most of the rivers in the northern states like Punjab and Uttar Pradesh are also vulnerable to occasional floods. It has been noticed that states like Rajasthan, Gujarat, Haryana, and Punjab are also getting inundated in recent decades due to flash floods. This is partly because of the pattern of the monsoon and partly because of blocking of most of the streams and river channels by human activities. Sometimes Tamil Nadu experiences flooding during November to January due to the retreating monsoon. Consequence and control of floods. Frequent inundation of agricultural land and human settlement, particularly in Assam, West Bengal, Bihar, and eastern Uttar Pradesh, flooding rivers coastal areas of Odisha, Andhra Pradesh, Tamil Nadu, and Gujarat, Cyclone and Punjab, Rajasthan, northern Gujarat, and Haryana. Flash floods have serious consequences on the national economy and society. Floods do not only destroy valuable crops every year, but these also damage physical infrastructure such as roads, rails, bridges, and human settlements. Millions of people are rendered homeless and are also washed down along with their cattle in the floods. Spread of diseases like cholera, gastroenteritis, hepatitis, and other waterborne diseases spread in the flood affected areas. However, floods also make a few positive contributions. Every year, floods deposit fertile silt over agriculture fields, which is good for the crops. Majuli, Assam, the largest riverine island in the world, is the best example of good paddy crop after the annual floods in Brahmaputra. But these are insignificant benefits in comparison on the grave losses. The government of India as well as the state governments are well aware of the menace created by floods every year. How do these governments generally respond to the floods? Construction of flood protection embankments in the flood prone areas, construction of dams, afforestation, and discouraging major construction activities in the upper reaches of most of the flood creating rivers, etc., are some steps that need to be taken up an urgent basis. Removal of human encroachment from the river channels and depopulating the flood plains can be the other steps. This is particularly done in western and northern parts of the country which experience flash floods. Cyclone centers may provide relief in coastal areas which are hit by a storm surge. Droughts. The term drought is applied to an extended period when there is a shortage of water availability due to inadequate precipitation, excessive rate of evaporation, and over utilization of water from the reservoirs and other storages, including the groundwater. Drought is the Drought is a complex phenomenon as it involves elements of meteorology like precipitation, evaporation, evapotranspiration, groundwater, soil moisture storage, and surface runoff. Agriculture practices, particularly the types of crops grown, socio-economic practices, and ecological conditions. Types of droughts. Meteorological drought is a situation when there is a prolonged period of inadequate rainfall marked with a maldistribution of the same over time and space. Agriculture drought. It is also known as soil moisture drought, characterized by low soil moisture that is necessary to support the crops, thereby resulting in crop failures. Moreover, if an area has more than 30% of its gross crop area under irrigation, the area is excluded from the drought prone category. Hydrological drought. It results when the availability of water in different storages and reservoirs like aquifers, lakes, reservoirs, etc., falls below what the precipitation can replenish. Take a look at figure 7.8, drought prone areas. Take a look at figure 7.7, drought. Ecological drought. When the productivity of the natural ecosystem fails due to shortage of water and as a consequence of ecological distress, damages are introduced in the ecosystem. Various parts of India experience these droughts recurrently, which result in some serious socio-economic and ecological problems. Drought prone areas in India. Indian agriculture has been heavily dependent on the monsoon rainfall. Droughts and floods are the two accompanying features of India climate. According to some estimates, nearly 19% of the total geographical area of the country and 12% of its total population suffer due to drought every year. About 30% of the country's total area is identified as drought prone, affecting around 50 million people. It is a common experience that while some parts of the country reel under floods, there are regions that face severe drought during the same period. Moreover, it is also a common sight to witness that one region suffers due to floods in one season and experiences drought in the other. This is mainly because of the large scale variations and unpredictability in the behavior of the monsoon in India. Thus, droughts are widespread and common phenomenon in most parts of the country, but these are most recurrent and severe in some and not so in others. On the basis of severity of droughts, India can be divided into the following regions: extreme drought affected areas. It is evident from the figure 7.8 that most parts of Rajasthan, particularly areas to the west of the Aravalli Hills, that is Marustali and Kutch regions of Gujarat fall in this category. Included here are also the districts like Jaisalmer and Barmer from the Indian desert that receives less than 90 millimeters average annual rainfall. Severe drought prone area. Parts of eastern Rajasthan, most parts of Madhya Pradesh, eastern parts of Maharashtra, interior parts of Andhra Pradesh and Karnataka Plateau, northern parts of interior Tamil Nadu and southern parts of Jharkhand and interior Odisha are included in this category. Moderate drought affected area. Northern parts of Rajasthan, Haryana, southern districts of Uttar Pradesh, the remaining parts of Gujarat, Maharashtra except Konkan, Jharkhand and Coimbatore Plateau of Tamil Nadu and interior Karnataka are included in this category. The remaining parts of India can be considered either free or less prone to the drought. Consequences of drought. Droughts have cascading effects on various other aspects of environment and society. Crop failure leading to scarcity of food grains, akal, fodder, trinkle, inadequate rainfall resulting in shortage of water, jalkal, and often shortage in all the three. Trickle is most devastating. Large scale death of cattle and other animals, migration of humans and livestock are the most common sight to be seen in the drought affected areas. Scarcity of water compels people to consume contaminated water, resulting in spread of many waterborne diseases like gastroenteritis, cholera, hepatitis, etc. Droughts have both immediate as well as long-term disasters consequences on the social and physical environments. Consequently, planning for drought has to take both aspects into consideration: provisions for the distribution of safe drinking water, medicines for the victims, and availability of food and water for the cattle, and shifting of the people and their livestock to safer places, etc. Etc. are some steps that need to be taken immediately. Identification of groundwater potential in the form of aquifers, transfer of river water from the surplus to the deficient areas, and particularly planning for interlinking of rivers and construction of reservoirs and dams, etc. should be given a serious thought. Remote sensing and satellite imageries can be useful in identifying the possible river basins that can be interlinked and in identifying the groundwater potential. Dissemination of knowledge about drought resistant crops and proper training to practice the same can be some of the long term measures that will be helpful in drought mitigation. Rainwater harvesting can also be an effective method in minimizing the effects of drought. Observe the methods adopted for rooftop rainwater harvesting in your locality and suggest measures to make it more effective. Landslides. Have you ever read about the blocking of roads to Srinagar or disruption of rails services by stone falling on the Konkan railway track? It happens due to landslide, which is the rapid sliding of large masses of bedrocks. Disasters due to landslides are in general far less dramatic than due to earthquakes, volcanic eruptions, tsunamis, and cyclones, but their impact on the natural environment and national economy is in no way less severe. Unlike other disasters that are sudden, unpredictable, and are largely controlled by macro or regional factors, landslides are largely controlled by highly localized factors. Hence, gathering information and monitoring the possibilities of landslide is not only difficult but also immensely cost intensive. It is always difficult to define in a precise statement and generalize the occurrence and behavior of a landslide. However, on the basis of past experiences, frequency, and certain causal relationships with the controlling factors like geology, geomorphic agents, slope, land use, vegetation cover, and human activities, India has been divided into a number of zones. Landslide vulnerability zones. Very high vulnerability zone, highly unstable, relatively young mountainous areas in the Himalayas and Andaman and Nicobar. High rainfall regions with steep slopes in the Western Ghats and Nilgiris. The northern eastern regions, along with areas that experience frequent ground shaking due to earthquakes, etc., and Areas of intense human activities, particularly those related to construction of roads, dams, etc., are included in this zone. High vulnerable zone. Areas that have almost similar condition to those included in the very high vulnerability zone are also included in this category. The only difference between these two is the combination intensity and frequency of the controlling factors. All the Himalayan states and the states from the northeastern regions, except the plains of Assam, are included in the high vulnerability zones. Moderate to low vulnerability zone. Areas that receive less precipitation, such as trans Himalayan areas of Ladakh and Spiti, Himachal Pradesh, undulated yet stable relief and low precipitation areas in the Aravalli, rain shadow areas in the western and eastern Ghats and Deccan Plateau also experienced occasional landslides. Landslides due to mining and subsidence are most common in states like Jharkhand, Odisha, Chhattisgarh, Madhya Pradesh, Maharashtra, Andhra Pradesh, Karnataka, Tamil Nadu, Goa and Kerala. Take a look at figure 7.9 landslide. Subsidence are most common in states like Jharkhand, Odisha, other areas. The remaining parts of India, particularly states like Rajasthan, Haryana, Uttar Pradesh, Bihar, West Bengal, except district Darjeeling, Assam, except district Karbi Anglong and coastal regions of the southern states are safe as far as landslides are concerned. Consequence of landslides. Landslides have relatively small and localized area of direct influence, but rock block restriction of railway lines and channel blocking due to rock falls have far-reaching consequences. Diversion of river courses due to landslides can also lead to flood and loss of life and property. It also makes spatial interaction difficult, risky, as well as a costly affair, which in turn adversely affects the development activities in these areas. Mitigation. It is always advisable to adopt area specific measures to deal with landslides, restriction on the construction and other developmental activities such as roads and dams, limiting agriculture to valleys and areas with moderate slopes, and control on the development of large settlements in the high vulnerability zones should be enforced. This should be supplemented by some positive actions like promoting large scale afforestation programs and construction of ponds to reduce the flow of water. Terrace farming should be encouraged in the northern hill states where jamming, slash and burn shifting cultivation is still prevalent. Disaster management. Disasters due to cyclones, unlike the ones caused by earthquakes, tsunamis, and volcanic eruptions, are more predictable in terms of the time and place of their occurrences. Moreover, with the help of development of techniques to monitor the behavior of cyclones, their intensity, direction, and magnitude, it has become possible to manage the cyclonic hazard to some extent. Construction of cyclonic shelters, embankments, dikes, reservoirs, and afforestation to reduce the speed of the winds are some of the steps that can help in minimizing the damage. However, increase in the loss of life and property in countries like India, Bangladesh, Myanmar, etc. in successive storms is largely due to high vulnerability of their population residing in the coastal areas. Disaster Management Bill 2005. The Disaster Management Bill 2005 defines disaster as a catastrophe, mishap, calamity, or grave occurrences affecting any area arising from natural or man-made causes or by accident or negligence, which results in substantial loss of life or human suffering or damage to whom and destruction of environment, and is of such natural or magnitude as to be beyond the coping capacity of the community of the affected area. Conclusion. On the basis of the above discussion, it can be conclude, concluded that disasters can be natural or the results of human activities, and all hazards need not turn into disasters. Since it is difficult to eliminate disasters, particularly natural disasters, then the next best option is mitigation and preparedness. There are three stages involved in disaster mitigation and management. Pre-disaster management involves generating data and information about the disasters, preparing vulnerability zone zoning maps and spreading awareness among the people about this. Apart from these, disaster planning, preparedness and preventative measures are other steps that need to be taken in the vulnerable areas. During disasters, rescue and relief operations such as evacuation, construction of shelters and relief camps, supplying of water, food, clothing and medical aids, etc., should be done on an emergency basis. Post disaster operations should involve rehabilitation and recovery of victims. It should also concentrate on capacity building in order to cope up with future disasters, if any. These measures have special significance to a country like India, which has about two-thirds of its geographical area and equal proportion of its population vulnerable to disasters. Introduction of the Disaster Management Bill 2005 and establishment of National Institute of Disaster Management are some examples of the positive steps taken by the Government of India. Exercises. Choose the right answer from the four alternatives given below: Bihar, Assam, West Bengal, Uttar Pradesh. In which one of the following districts of Uttaranchal did Malpa landslide disaster take place? Bageshwar, Almora, Champawat, Pithogarh. Which one of the following states receives floods in the winter months? Assam, Kerala, West Bengal, Tamil Nadu. In which of the following rivers is the Majuli River Island situated? Ganga, Godavari, Brahmaputra, Indus. Under which type of natural hazards do blizzards come? Atmospheric, terrestrial, aquatic, biological. Answer the following questions in less than 30 words. When can a hazard become a disaster? Why are there more earthquakes in the Himalayas and in the northeastern region of India? What are the basic requirements for the formation of a cyclone? How are the floods in eastern India different from the ones in western India? Why are there more droughts in central and western India? Answer the following questions in not more than 125 words. Identify the landslide prone regions of India and suggest some measures to mitigate the disasters caused by these. What is vulnerability? Divide India into natural disaster vulnerability zones based on droughts and suggest some mitigation measures. When can development activities become the cause of disasters? Project activity. Prepare a project report on any one of the topic given below. Malpa landslide, tsunami, Odisha and Gujarat cyclones, interlinking of rivers, Tehri Dam or Sardar Sarovar, Bhuj or Latur earthquakes, life in a delta or riverine island. Prepare a model of rooftop rainwater harvesting. Appendix 1 states their capitals, numbers of districts, area and population. State capital, number of districts, area in square kilometer, population. Andhra Pradesh, Hyderabad, 23, 2,75,045, population 845, 80,777. Arunachal Pradesh, Itanagar, 16, 83,743, 13,83,747. Assam, Dispur, 27, 78,438, 312,05576. Bihar, Patna, 38, 94,163, 10, 40, 99, 452. Chhattisgarh, Rajpur, 18, 1,35,192, 255, 45, 198. Goa, Panji, 2, 3,702, 14,58,545. Gujarat, Gandhinagar, 26, 1,96,244, 6460439, 692. Haryana, Chandigarh, 21, 44,212, 253, 51, 462. Himachal Pradesh, Shimla, 12, 55,673, 68, 64, 602. Jammu and Kashmir, Srinagar, 15, 2,22,236, 125,41, 302. Jharkhand, Ranchi, 24, 79,716, 329,88, 134. Karnataka, Bangalore, 30, 1,91,791, 6, 10, 95, 2, 97. Kerala Thiruvananthapuram 14, 38,852, 3, 34, 06, 601. Madhya Pradesh Bhopal 15, 3,08,252, 7, 26, 26, 809. Maharashtra Mumbai 35, 3,07,713, 11, 23, 74, 333. Manipuri Imphal 9, 22,327, 28,55,794. Meghalaya Shillong 7, 22,429, 29,66,889. Mizoram Aswal 8, 21,081, 10,97,206. Nagaland Kohima 11, 16,579, 19,78,502. Odisha Bhubaneswar 30, 1,55,707, 4 crore 19,74,218. Punjab Chandigarh 20, 50,362, 2 crore 77 lakh 43,338. Rajasthan Jaipur 33, 3,42,239, 6 crore 85 lakhs 48,437. Sikkim Gangtok 4, 7,096, 6,10,577. Tamil Nadu Chennai 32, 1,30,060, 7 crore 21 lakh 47,030. Tripura Agartala 5, 10,486, 36 lakh 73,917. Uttarakhand Dehradun 13, 53,483, 1 crore 86,292. Uttar Pradesh Lucknow 71, 2,40,928, 19 crore 98 lakh 12,341. West Bengal Kolkata 19, 88,752, 9 crore 12 lakh 76,115. Note: Telangana became the 29th state of India in June 2014 and its capital is Hyderabad. Appendix 2. Union territories, their capitals, area and population. Union territories capital, number of districts, area in square kilometer, population. Andaman and Nicobar Islands, Port Blair, number of districts 3, 8,249, population 3,80,581. Chandigarh 1, 114, 10,55,450. Dadra and Nagar Haveli Silvassa 1, 491, 3,43,709. Daman and Diu Daman 2, 111, 2,43,247. NCT Delhi 9, 1,04,083, 1 crore 67 lakhs 87,941. Lakshadweep Kavaratti 1, 30, 64,473. Puducherry 4, 490, 12,47,953. Water availability basin wise. Name of the river basin, average annual availability cubic kilometer per year. Indus up to border 73.31, Ganga, Brahmaputra, Barak and others 525.0 to 585.60, Godavari 110.54, Krishna 78.12, Kaveri 21.36, Pennar 6.32, east flowing rivers between Mahanadi and Pennar 22.52, east flowing rivers between Pennar and Kanyakumari 16.46, Mahanadi 66.88, Brahmani and Baitharni 28.48, Subarnarekha 12.37, Sabarmati 3.81, Mahi 11.02, west flowing rivers of Kutch, Sabarmati including Luni 15.10, Narmada 45.64, Tapi 14.88, west flowing rivers from Tapi to Tadri 87.41, west flowing rivers from Tadri to Kanyakumari 113.53, area of inland drainage in Rajasthan desert negative, minor river basins drainaging into Bangladesh and Burma 31.00, total 1869.35. State union territory wise forest cover area in square kilometers, you can see this details here, and state wise details of the protection area network of the country, you can see full details here. Now you can study glossary. Alluvial plain, a level tract of land. You can study glossary here very well. Thank you.